Good morning. At least it's morning for me. So some of you guys have texted me about, the animals in the background and how it's funny and blah, blah, blah. And you wanted to see what the barn looked like. So I'm just going to kind of take you of a little tour of the barn. So up against the wall, the whiteboard is normally where our chore list goes, but the chore list is gone for now, and I'm using it for class. And then we have a couple different bays in the barn. Back there is the animal center. You can see some cages back there. The kids are playing ping pong in here, so right now the ping pong table is here, but normally there's a tractor in here. More animal cages. Let's see. All sorts of stuff that we've collected over the years. There's our trophy wall for different things that we've won. I told you they delivered hay the other day. Here is the hay. Here is Handsome. So Handsome comes out and watches me. Handsome likes people a lot, so he likes to be out here. Alex, Handsome says hi to you. Alex has met Handsome. Over there is our woodworking and shop area. It looks kind of messy right now because we are woodworking. But anyway, and then there's the outside. So there's where the animals come running in. But anyway, there's just kind of a panorama. There's crap everywhere, but it's just the way it goes. There's a panorama of the barn so that you can see it. But yeah, so that is where I am. Okay, hold on. Now let me get that straight again. All right. Okay, so we have been working in chapter 3. We did it out of order. We did 3.2, 3.3, 3.4, and now we're going to come back to 3.1. Now, in 3.1, they do one thing that is supposed to be nice to you, but in the same step, they make it more difficult on you. So I'm going to show you both ways. Neither one, I would say, is truly simpler than the other because they both have their good aspects and their bad aspects. But anyway, I'm going to show you both ways. Okay, so we are, excuse me, graphing polynomials. So we've talked about finding the zeros of polynomials, how many zeros there would be, synthetic division, all of that. And now we're going to graph some of these guys. So before we just jump into putting up a polynomial and graphing it, we have one thing that will help us in our graphing that's new. The rest of it, I think we've already done all of that. And this is called the leading coefficient test. And the leading coefficient test is written, again, really horribly. But once I break it down for you, all of a sudden you're like, well, that's easy. Okay, but I got to write it out. So we'll write it out, then I'll show you what it means, and you never have to look at the written out again. Okay, so we're going to say if we have a polynomial, and we're going to use that drawn out form where we went a to the n, x to the n minus 1, plus a to the n minus 1, x to the n, oops, that was supposed to be an n, sorry, n minus 1, dot, dot, dot. So basically just saying, if you have any polynomial, the leading coefficient is this guy. We're not worried about any of the rest of it, just that a sub n. So now there's 4 different parts to it, which is kind of annoying. So first, if a sub n is greater than 0 and n is even, then, that is not then the polynomial, which we'll abbreviate as poly, the polynomial increases as x approaches plus or minus infinity. Now, like I said, it looks all like ugly worded there, and we'll talk about that. So then the second one says, if a sub n is less than 0 and n is even, then the polynomial decreases as x approaches plus or minus infinity. Third, if a sub n is greater than 0 and n is odd, the polynomial increases as x approaches infinity and decreases as x approaches negative infinity. One more. Fourth, if a sub n is less than 0 and n is odd, the polynomial decreases as x approaches infinity and increases as x approaches negative infinity. Holy cow. Okay, so all of this going to infinity in both directions and everything, basically what we get from this is on the edge of the graph, when you draw a graph and you know how you have the arrows going, you know, like both up or one up and one down or that kind of thing, that's what this graph tells us. What are the arrows doing at the edge of your graph? Or what's what this test tells us. But you don't have to use it in this long drawn out form. We can use what we call families instead, families of polynomials. So let's look at this first situation. This first situation is talking about when n is even. N is even means that first exponent is even. Now, our most basic n is even function is f of x equals x squared. Base function, right? This is one we're supposed to know. So over to the side, we can immediately say it looks like that. Now, what we're noticing is the arrows are both going up. And look what this says. The polynomial increases as x goes to negative or positive infinity. The graph is increasing the whole time. Now that's for x squared, but because they're families, this is going to work for any even number. So if this was x to the 22nd, it's going to work. If this was x to the 224th, this is going to work. It's always going to be pointed in the same direction because these guys are all a family. And that's what that first part says. They're all going to have that basic idea of the problem. Now, what happens in between might be a bunch of squiggles. There might be a bunch of squiggles, but on the ends, it's going to point up. But then this next part says it decreases, but look what it does to the leading coefficient, and let's think about one of our most basic transformations. What happens if we go negative x squared? What does that do to our parabola? So anytime there's a negative out front, but this is an even number, whoop, all we've done is flip it down. Getting the idea here? And again, 24, 2000, anything that's even, it's all going to have these arrows going down. All right, then the third one is talking about if n is odd. And our most common odd guy, that is a really big 3, is x cubed, isn't it? X cubed, another one of our base graphs. So when you see x cubed, you should immediately be thinking like this. Now notice, it's going up on this side and it's going down on that side. That's what this is saying. It increases as it goes this way and it decreases as it goes that way. So that is just a visual of what we see here. But then once again, what happens if we slap a negative sign on the front? Doesn't this guy flip over? So now he looks like that. Doesn't matter if this is 3, 5, oh no, I said I should have written n is odd, n is odd. 3, 5, 11, 331, whatever it is, they're all gonna have arrows that follow the same pattern as x cubed. So families of polynomials means we don't need to look at it in words, we can just think about our base graphs. Excuse me a second. Okay, base graphs is what we're focusing on here. But that's going to help us understand what's going on the edge of our graphs. Okay, so we've got the leading coefficient test. Oops, let's give it a little squirt, squirt. Squirt, squirt, squirt. All right, shouldn't say anything, but it's a nice quiet morning this morning in the barn. Okay, so if we're going to graph polynomials, the first thing is the leading coefficient test. The next thing is the y-intercept, I'm sorry, there's only one y-intercept. Okay, so we've got this, and then the last thing is the x-intercepts. And these are the zeros of the polynomial. So these x-intercepts are what we just spent the last 3 lectures looking at. We're finding these x-intercepts. Okay, so these are the zeros. But there's one thing that goes along with this. So if you remember from, I can't remember which, if it was the first or second lecture of 3.3, 3.4, we talked about multiplicity. And we said that sometimes a zero occurs more than once. Okay, and that becomes important when it comes to the graph, okay? So we saw an example, I think, where 2 was an answer 3 times, so it had multiplicity 3. So when it comes to the graph, the multiplicity also becomes important. So it says if x is a 0, wait, no, let's not write it that way. Let's actually use proper grammar. With odd multiplicity, the graph crosses the x-axis. Okay, that's the norm. That one you don't really have to worry about. It's the other one that we need to see. So if x is a 0 with even multiplicity, the graph touches but does not cross the x-axis. And maybe that makes sense to you in words, but if it doesn't make sense to you in words, guess what we've got? We've got our 2 base functions to help us out again. So let's go over here and have a look at this again. Apparently the black pen doesn't come off super easy. Okay, so let's say that our polynomial, or the guy that we're solving for, is x squared equals 0. Okay? Now, x equals 0, right? But how many x's are actually there? Couldn't we write that as x times x? So if it's x times x, wouldn't we also have a secondary x equals 0? Now, we don't normally say that because it kind of seems dumb, but there is a multiplicity going on there, right? Now, this is also our base graph, so we know that the graph looks like, helps if I actually, you know what, I'm just going to make it more, looks like that. There's our graph. Here is our x-intercept at 0. What did the graph do? It comes down. Does it cross through? No. It comes down, bounces off, and goes back in the other direction. So if there's even multiplicity, it was an answer 2 times, the graph touches but does not cross. Okay. Our other one, x cubed equals 0, that's like saying x times x times x, isn't it? So on this one, x equals 0 with oops, I didn't dry this well enough. With multiplicity 3, That's odd, isn't it? And we know that when we draw this little graph, at 0, it crosses right through. So that's what it means by crosses through or bounces and touches and bounces off. Okay, so we've got everything we need now. Now it's time to put up a polynomial. So let's graph something. What I got here? Let's see. Oh, my shoe came untied. Give me a second. Okay, so like I said, the book tries to make this a little easier on you, and then in their way, it kind of makes it harder on you. So the one of the ones the book gives you looks like this. Y equals 2x plus 1 squared times x minus 3. Now, they're doing this to make the x-intercepts easy to find. So it's already in factored form. So the x-intercepts are going to be easy for us to find because we can just set each piece equal to 0. So if we set 2x plus 1 equal to 0 and x minus 3 equal to 0, so this is going to be our x-intercepts. Here we're going to get x equals negative 1/2. Okay. But how many times? What does this little 2 imply? How many factors are there? There are 2. So this has mult 2, okay, or an even multiplicity. And this one is just x equals 3. So if we're going to draw a nice size graph here, now this is not going to be just a little sketch. This is going to be plotted points. You're making this one look pretty for me, okay? So nice big graph. Okay, nice big graph. We know that if here's one, that we've got an x-intercept there, and then we have another x-intercept way over here. All right. And we know because that's even multiplicity that this guy is going to do a little bounce. I call it a bounce. You can call it whatever you want. Touch, bounce. Okay. But what happens is the leading coefficient test and the y-intercepts all of a sudden become a little bit more challenging. So the leading coefficient test, we don't have to multiply the whole thing out, but what we need to do is we need to look at the leading terms. And then, so we're going to use the leading coefficient test. And we're going to say that we have a 2x, but don't forget that it's squared. And then we're going to have an x. The rest of the terms we don't care about, just those leading coefficients. So it's going to be 2x cubed. So if we were to multiply this out, hold on, the dogs are barking at sunburned or something. See, I shouldn't have said it was going to be quiet today. Wake up! Guys, I have to push pause. They have caught a squirrel. I'll be back in a minute.